In this video, we're going to learn about translating designs in the UML modeling language into relational schemas. As a reminder, if the application developer is using a high-level design model, then they will create their design usually using a graphical language that's sent to a translator, and the translator will then produce a schema using the data model of the underlying database management system, which frequently is relational. So in our case, we're looking at high-level design in the UML data modeling subset, which is then translated to relations and installed in a relational database system. It's this translation process that's the topic of this video. In the data modeling subset of UML, we have 5 concepts that we learned in the previous video, and we'll see now that designs using these concepts can be translated to relations automatically with one provision, which is that every regular class has a key, and we'll see what we mean by a regular class in a moment. So what we're going to do is go through each one of these concepts one at a time and show how the concepts are translated to relations. For our examples, we'll use primarily the same examples that we used in the previous video where we introduced UML. For classes, we'll have a student class and we'll have a college class. Our students have a student ID, which is the primary key, a student name, and a GPA, and our colleges will have a college name, which we'll assume is unique, so that's the primary key, the state, and the enrollment. The translation from classes to relations is absolutely direct. We take the student class and we make a relation called student. We put the 3 attributes down for that relation, and then the primary key from the student class becomes the key attribute in that relation. And similarly, our college relation has the college name as a key, the state, and the enrollment. So all we're doing to turn classes into relations is basically turning them sideways. So now we're done with classes, and let's move on to associations. We'll see that each association is going to be translated to its own relation that grabs a key from each side of the association. So let's go to our example, the same one we used earlier, that has students applying to colleges. So here's our UML diagram with students applying to colleges, and we'll already have generated the 2 relations for our classes, the student and the college relation, and for the association applied between students and colleges, we create a relation, we call it applied, and that relation has as attributes the keys from both sides. So that would be the student ID from the student class and the college name from the college class. And if you think about it, that makes a lot of sense. Applied is capturing relationships between students and colleges, so we'll capture each one of those relationships with one tuple in the applied relation, identifying the student with the key and the college with the key. Now, one question you might have is, what is the key for a relation that we generate from an association? It turns out that depends on the concept of multiplicity that we learned about in the previous video. So let me set up a generic example of 2 classes with an association, and then we'll talk about multiplicity and keys. Okay, so here we have our 2 classes. We'll call them C1 and C2, and each one has a key attribute. We've called it K1 and K2 over here, and then one other attribute, O1 and O2, and then we have an association A between the 2 classes. So in terms of the relations that would be generated, we'll have for C1, K1, O1 with K1 as a key. For C2, we'll have K2, O2 with K2 as a key. And then for our association A, we'll grab the key from each side, K1 and K2. And the question we have now is, what is the key for relation A? Well, as a default, the key can be both attributes together, but in certain cases we can be more specific. And again, that's going to depend on the multiplicity on our association. Let's suppose that our multiplicity is 0.1 on the left-hand side and a star on the right-hand side. And let's look at what that represents in terms of the type of relationship we're capturing. And I'll make sure to get it right this time. So what this is saying here is that if we have objects of C1 on the left-hand side, each one can be related to many objects of C2 on the right-hand side, but each object of C2 can only be related to at most one object of C1, and some of them might not be related to any. So remember now, it's these edges that are being captured by the tuples in our relation for the association. And we can see that each element on the right-hand side then can be involved in at most one tuple of A. So that tells us that K2 is actually a key for A. So when we have 0 dot dot 1 or 1 dot dot 1 for that matter on the left side or on one side of an association, then the key attribute from the other side is a key for the association. So let's test out that rule on our student and college association and see if it makes sense. So I've drawn the association here, and we're interested in the relation that's going to be generated for the association itself, which will be the applied relation with the student ID on one side, and the college name from the other. So that's the relation that we're going to generate for the association, and our question is, what's a key for that relation? Well, let's add the constraint that every student applies to exactly one college. So that would be a 1 dot dot 1 on the right, and then a star on the left, if a college can have any number of applicants. So our rule of thumb, it's actually a rule, said that if we have 1 dot dot 1 or 0 dot 1 dot dot 1 on one side, then the other side would be the key. So that would tell us, if we have this 1 dot dot 1 on the right, that student ID would be a key for applied, and indeed that makes complete sense. If each student can only apply to one college, then they will indeed be a key in the applied relation. Now there's actually a related concept here where we might not need a relation for associations at all, and again that depends on multiplicity, and again let's start with a generic example. So here's our generic example, and from this our standard translation would give us 3 relations, one for C1, one for C2, and then one capturing the association A, which would have a key from each side. Now what we're going to discover is that in some cases it's actually possible to fold relation A into either C1 or C2. We'll end up with just 2 relations instead of 3, and we'll be capturing the same information. So let's suppose that we have a 1 dot dot 1 on our left-hand side. So again, we're going to have the situation where from the left side to the right we have a fan out. So each one on the right is related to exactly one on the left. If that's the case, then instead of having a separate relation for the associations, basically for capturing these edges here, we can simply take the related element from the left, the key from the left, and add it to the element for the right. Let me show how that's done. So what we'll do is we'll change this C2 to have K2 and O2 as before, but also to have the key from the left-hand side of class, or relation, so the key from C1, and then we don't need A any longer. And we can see why that works, because every element in C2 is related to exactly one element in C1, so we just add the key for that single element that is related to that relation. Now, what if the left-hand side were 0 dot dot 1 instead of 1 dot dot 1? In that case, it would be possible for there to be some elements in C2 that aren't related to any elements in C1, and that would still be okay with this design as long as null values would be allowed in the third attribute of the relation for C2. And finally, what's the key for this relation? Well, we knew before that the key for C2 was K2, just by definition of it being the primary key for the class, and that's still the case in the expanded C2. K2 will still be a key because we'll only have one instance of each object and the one K1 that it would be related to through the association. So what we saw, to summarize, is that when we have 0 dot dot 1 or 1 dot dot 1 on one side, and then we have an association, instead of making a relation for the association, we can add the key from the side with the 0 dot dot 1 or 1 dot dot 1 to the relation that we generated for the class on the right-hand side. So let's take a look again with students and colleges just to confirm this intuition. So let's again suppose that a student applies to exactly one college, and our rule of thumb says that we have a 1 dot dot 1 on one side. Then we can take the key from that side and add it to the relation for the other side. So we would be adding to the student relation the college name attribute, and we'd be getting rid of applied entirely. And let's just think about it, if that makes sense. If every student is applying to exactly one college, it makes perfectly good sense to just add that college name to the student relation. And furthermore, if we had students just applying to either 0 or 1 college, that would still be an acceptable design, provided that null values are allowed for the college name attribute.